There's a few people still dribbling in, so let's begin. Welcome, good afternoon everyone, to the 5th Interdisciplinary Engineering Colloquium hosted by the School of Engineering Education. The colloquium this year, the title of which is up here, is Boundary Agents, the Transformative Potential of Professors of Practice in Engineering at Purdue. So over the last number of years, Purdue has hired 10 professors of engineering practice, clinical professors if you will, and they're distributed around the college, so we tend not to know that they're there, so this was a chance to get them all together. These groups understandably come from a diverse, eclectic range of backgrounds, and they really bring some fresh thinking into the college. They've got lived experience which might cause us to challenge us to think about where we're coming from in our normal way of doing business. So the purpose of the colloquium, or the goals this afternoon, are really twofold. One, to introduce this cadre of professors of engineering practice, hopefully to some people who they haven't met before, and also to catalyse a conversation. A conversation about how these boundary agents might really be used to great effect in the college. Interdisciplinary work depends on boundary agents, that is to say individuals who can work really effectively between the disciplinary silos. And seeing as work in industry is not organised by nice disciplinary things, mechanical, electrical, civil, etc., they might come here and bring us some other fresh perspectives. So that's what we're trying to do. So we have a number of them here today, some on stage, and I'll explain what's going to happen there in a moment, and some others. So if you're a professor of engineering practice at Purdue, please wave your hand so everybody can see who you all are. So we have several down here. And what I want to, well, I'll explain that in a moment. So I want to acknowledge Professor Bruce Johnson, who gave an endowment to the School of Engineering Education to help with graduate education, and we used part of the monies from that to fund this event. And Bruce is an alumnus of mechanical engineering, did his master's and his PhD here at Purdue, and he's a professor emeritus from the US Naval Academy. He would like to have been here today, but he's unable to, but he'll be online because we're streaming this event as well as recording it. I'd also like to acknowledge the members of the Industrial Advisory Council for the School of Engineering Education who are here. And we actually have 3 of the 4 ever directors of interdisciplinary engineering, if you want to say. Dick Grace, Paul Wonka, and Mary Pillot, so all in the room at the same time. So the format of this colloquium is that in a few minutes I'm going to sit down and each of the professors, the ones who are here and a few who can't be here, are going to introduce themselves via video, say briefly something about themselves. Then I'm going to lead a panel discussion where the 4 representatives on stage will dig a little deeper into those backgrounds. We'll then have a second video where the various professors of engineering education talk a little about their ideas, their vision of how they might be able to contribute to new ways of doing education here. Again, we'll dig into it a little deeper with the panel, and then after a very brief wrap-up, what I really want to do is then get you all talking. So rather than having Q&A, and seeing as we have some people who aren't on the panel, I'm going to make it fairly short today so we can then go over and have some refreshments over here and we can chat. So this really is to start a conversation. So with those words, what we'll do is go to the introductory video and you'll get to meet the 10 professors of engineering practice at Purdue.
Hi, I'm Andrew Brightman. I'm the assistant head in the Weldon School of Biomedical Engineering and an associate professor of engineering practice. Been with the school for a number of years. My background's in tissue engineering and worked in the pharmaceutical industry. I've done consultant for tissue engineering companies and most recently been working on curricular development, starting a new school of biomedical engineering.
I'm Brad Durstock. I'm an associate professor of engineering practice in the Weldon School of Biomedical Engineering and the School of Industrial Engineering. My focus of my research is assistive technology or rehabilitation engineering, which is to provide solutions to help people with disabilities.
Hello, I'm Dan Dumbacher, professor of engineering practice in the School of Aeronautics and Astronautics, and I came to Purdue after 33 years at NASA, starting off with my mechanical engineering degree doing propulsion systems work for the shuttle main engines prior to the first shuttle flight, all the way through to my last job at NASA was leading the development and integration of the spacecraft and the rockets to take people to Mars.
I'm Bob Kenley. I'm a systems engineer in industrial engineering. I have many years of industry practice. I studied management, statistics, and systems engineering. I worked at Lockheed for many years as a research systems engineer. I worked on advanced projects that had many issues with them that needed to be solved with research. From my experience there, I can see that research that our doctoral students are doing here at Purdue in interdisciplinary fields is absolutely essential for industry like Lockheed and other places that I have worked.
Hello, my name is Enrico Martinez. I'm a professor of engineering practice in the School of Chemical Engineering. I'm from Mexico. I got my PhD at the University of Notre Dame, and I've been visiting professor for several U.S. universities and an Italian university. And I'm here mainly because of a combination of my academic experience and my industrial experience of 19 years.
I am Robert Patty, the Beavers Heavy Construction Distinguished Fellows. I have provided construction engineering and management services or design services on several continents throughout the world, and worked on major projects from a few million to several $billion, and discussed and provided services as an executive in the construction industry as well as a construction manager.
My name's Mary Pilot, and I'm an associate professor of engineering practice in the School of Engineering Education. I'm also the director of E&E's undergraduate engineering program in interdisciplinary engineering studies and multidisciplinary engineering. I spent 25 years in industry, working in a range of types of companies and industries, from aerospace and airlines to industrial products, and also in the Japanese automotive sector.
I'm Ted Widener. I'm a professor of practice in construction engineering and management. I came to Purdue to teach after over 30 years running and maintaining higher education facilities across the U.S., 6 different campuses.
So if we dig a little deeper, I'm going to ask the panelists a question and get them to respond. So Brad, tell us a little bit more about this work in assistive technologies. What does it really encompass?
Okay. Well, like the video says, it's any technology to help a person with a disability. Now even though that's kind of small in scope, it's actually very broad because there's a lot of different disabilities, everything from mobility, sensory, learning disabilities, other cognitive disabilities. And each disability encompasses a lot of sophistication of the technologies, from very low tech to very high level technologies. And so it's an area that is a means to solving a problem, but to kind of give a little background to how I kind of got into it, I've been using assistive technologies for 25 years, but when I was studying neuroscience as a graduate student, I realized I need specialized assistive technologies to do kind of the practical work that's required in science and engineering. mostly really for microscopy. And it was not only to allow me to use a microscope, but it was to help me learn all the nuances of microscopy. So it goes a little deeper. It allows this practical understanding that a lot of people with disabilities don't really understand the limitations of the instruments that you use. How do you prepare specimens? And so it's really, I knew I was lacking some of these practical learning experiences. And so that's really got me really interested in pursuing assistive technology as a research discipline.
Clearly a lot more there than meets the eye. So Dan, you said you worked on the shuttle main engines, and towards the end of your career looking at the integration of a system to get us to Mars. So how do you manage that transition across your career, that range of things?
Actually, you don't manage that transition, it just happens to you. And the way it came about was because of the technical fundamentals that I learned here at Purdue, and then being thrown into a very highly interdisciplinary teamwork environment and just learning to work with that and being eventually brought into, well, you've been doing well on the interdisciplinary part, now we're going to throw you into the policy part and make you come to Washington, D.C. so that you help us get to the next step, because to do the rocket science, to do the exploration, be it robotic or human, there are some fundamental policy decisions, particularly when it comes to funding. And so you have to get into the middle of that. So I ended up learning that on the fly, thrown into the fire, shall we say. And then you end up getting that practical experience, and what you learn over time is that the next generation to carry this exploration endeavor to the next level is help them understand, at least make them aware of the interdisciplinary aspects that they will face, so that when they start, they are building it from the beginning and not having to just learn it because they're there and getting it by osmosis. So that's put the wrapper on the fundamentals. The fundamentals form the basis, but then this is about putting the wrapper around things and the context and the why we do what we do from an overall policy perspective.
Right. So, Mary, picking up on this interdisciplinary theme, given the variety of experiences and industries that you mentioned, that you've worked in, how does that prepare you to be the director of the interdisciplinary engineering program?
It was all part of a grand plan, right? Not so much. No, I had the opportunity to work in and out of so many different departments across my career and across industries. And you figure out pretty quickly that whether you're in finance or whether you're in marketing or whether you're in product development, that it attracts certain types of people. And within those groups of people, there are emergent cultures. And so you begin to learn how to navigate those cultures and find comfort between those boundaries, if you will. And so now in multidisciplinary engineering, we have students who already see themselves in very unique ways. Perhaps sometimes they feel different or as outliers because they see themselves in very interdisciplinary ways. And so I think my background helps me help them see that there's a place for them beyond school, and that even though they may look very different now because they fall outside of the traditional disciplinary space, the world of work and the world of engineering practice doesn't put you in silos. In fact, it breaks down those silos and expects you to work cross-functionally. So I think whether I knew it or not, I was being uniquely prepared for that role.
So again, on the interdisciplinary theme, Bob, you mentioned that a lot of the work that's going on in doctoral programs here, particularly the interdisciplinary stuff, really needs to be getting into industries. And so would you like to expand on that a little bit?
Right. Well, you got a big system out there. You've got all these things, right? You've got hardware that mechanical engineers do. You've got software that maybe people in ECE understand. They probably don't. You've got cyber physical systems, that's the buzzword now, right? And then you got, oh gosh, you've got humans that are in the middle of all this operating it. You got plants and animals that are affected by it. My goodness, that's the system there. And then good engineers, well, it's the exchange of matter and energy, right? Maybe some information. Oh yeah, there's money that's exchanged while you're operating these systems. And it takes time. Look at all these dimensions that are going on here. And these are all interconnected across the globe now. And of course, if Dumbacher has his way, it's interconnected across the solar system, all this activity.
No, we're going beyond.
We're going beyond, okay. Way beyond.
Way beyond.
Okay. So there's great opportunity for companies to take advantage of this, but there are huge risks. Look at all the things we don't understand, we don't know. I worked on one project that's called Yucca Mountain. We were to store nuclear waste for 10,000 years. Has any graduate student ever been asked to design materials that will last 10,000 years, to withstand below ground and above ground shocks and events? What about a person wanders by a few hundred years later, never heard of this place? What kind of signage do you put up to warn them that something's going on there? And we had to do trade-offs for our budget well past 120 years to make sure that it was sustainable. How do you trade off something that's built today for operating costs 120 years later? We had to dig in deep into economic literature, social science literature to understand how to do that. I mean, all these questions come, they call me and say, Kenley, we've got a tough problem to work on. We don't know what it is, but we think we need some research. And doctoral students in engineering need to be able to deal with those kind of research problems. They need to get out of the lab and see these projects and bring to bear a lot of disciplines. All these wrapper disciplines like engineering economics and other things they're getting to check the box, they actually come in quite handy when you get out there.
So we've heard from all of you that you have a career that maybe starts in the very technical and inevitably gets in these very complex, very integrated, very multidisciplinary fields. So you come back to the academy with this expanded brain, with this range of things. How do you bring that back into the classroom and where you're doing a lot of technical things? So just anyone, I won't pick on you if you want to just have a go at how do you bring that expansive experience to bear back in the classroom? Who wants to go first?
Well, one of the ways I try to bring it back into the classroom, and we'll leave it to the students as to whether I do a good job or not, is by taking them and having them work through specific projects that have real-world application. For example, last semester, the president of this university chaired a National Research Council report on the future of human space exploration. A very well done, a very comprehensive. It included input from across the stakeholder base about what we should be doing as a nation for human exploration. So we gave that to the students and said, okay, we're not going to talk about giving you a set of requirements and having you go design something to go meet those requirements. We want you to take this report as a basis, take some legislation at the congressional level, and I want you to think through what you want exploration to be, and make them think through the stakeholder analysis, make them think through how they come up and address the different perspectives, what are the options for those perspectives, force them with interdisciplinary teams to come up with solutions and options, and then frankly have them come up with a communications plan. I scared them one day when I walked in and I said, by the way, all you engineers, I want you to write a 500-word editorial to advocate for your position to be published in the Washington Post. And I got silence. But then after a few minutes, they looked at me and said, okay, we get it. You want us to figure out how to communicate concisely. You want us to be able to talk about and advocate our positions in layman's terms. And I said, exactly, that's what we're after. So if you take them through that practical program, project kind of approach, and you have to do it in chunks, but it gives them that exposure and forces them thinking outside the box a little bit. You kind of do it, and believe me, I actually took I have some of those editorials they wrote, and a few friends of mine are going to get them. because they're pretty good.
Others on the topic of how do you bring that wealth of experience to bear here and now in a classroom?
Well,
Brad.
from kind of my world, there's a lot of senior capstone classes and epics here that students kind of gravitate to assistive technologies. I think they like the service learning aspects and they see a real definite problem. But, be able to step into the shoes of the end user, that becomes more of a challenge. And that the end user is not someone who simply, evaluates how good a job they've done with their device, but they should be integrated in this user-centered design during the development process. And so I think that sometimes is a lesson they have to learn that, this is, you have some ideas, but really make sure you know the problem before you dive in. And that's sometimes difficult for engineers who can only come up with a myriad of possible solutions.
Building on that a little bit is the notion of not just external customer, but internal customer. And so oftentimes, students will think about a solution without regard to those gnarly marketing people or, the supply chain folks or even the IT system that has to support, development of the product or moving it through the company or managing the inventory. And so, in the classroom, we create something that I call day in the life of an engineer. And so as they work towards a solution, they have this wonderful moment where they feel really strong about their solution, and then I pop on them some scenario like, oh, Bob in environmental health and safety just told you that, we're now emitting particulate through our stack and you can't do it like this anymore. Now what are you going to do? Those are real situations that they're going to face, and having them think about and respond to and deal with those situations now helps them practice for the future because, as Ted said in the video, now's the time to practice, right? You practice when you don't have a mortgage and a car payment. That's not when you want to practice being good at something. So.
Right. Well, they've only unleashed me on graduate students so far, thank heavens. And really, these grad students come in and they've got a pretty good grade point average and they think they know a lot. And then I teach them that they don't know much of anything. Technically speaking, there's a lot of technical skills that they're not getting to help them solve these complex problems. And there's actually theory, mathematics, there's skills out there that they need to learn. And they get really frustrated when they can't use what they use as a junior in undergraduate school to work on problems. So I challenge them to do that, and I march them through it, and I make sure they're precise, concise, and logical all the time, and I give them problems that there's no cookbook answer for. Then I bring in problems that I worked on, like the Yucca Mountain problem, all these other complex systems, all these applications where it required new research to actually solve the problem well beyond the scope of what they've ever done in a laboratory in their work around here.
That's great. So what we're going to do now, we've heard the background, we've heard some of how you apply that in the classroom. I want to move us to start thinking about what are the other things that we can do beyond just bringing that expertise in the classroom to fundamentally start to think about how we educate. Maybe we could transform it. So we'll go to the video and we'll see some of the vision statements or the ideas that this whole community has.
My vision is to help train the engineers at Purdue to be more aware of the ethical, regulatory, and societal impact of their engineering practice and design. A training that helps them think about those issues all the way from the beginning of the design through the implementation. We have a unique opportunity here to train students who are going to use their engineering to impact medicine, particularly in our partnerships with the School of Medicine, engineering is becoming a bigger and bigger part of medicine, and our students need to understand what it means to design medical technologies that are going to have long-term impact.
The reason why I like assistive technology or rehabilitation engineering is, first, it provides solutions to people with disabilities to overcome their functional limitations, but also provides a different way of looking at general areas of engineering. I think students gravitate toward looking at assistive technology projects. One, because of the problem-solving element, and two, because they see immediate impact on the person that they serve. And this could be a specific clinical case, or it could be for a general usage. But they see, okay, this is the work I've done, and this is how I made someone's life better.
What I would like to do as a professor of engineering practice is help today's students understand the why and the context for why they do the technical work that they do, and also bring together the other disciplines like liberal arts and business aspects that are so essential to solving today's complex problems and working on today's issues.
So my goal here as a professor is to get our graduate students connected with industry, work on applied problems and systems that are facing our industry. This is quite a bit different from the current method of teaching graduate students where they come into the lab and we lock them up for 3 or 4 years on a grant and never let them out. So that's my hope as a professor of practice.
I'm the director of the Chemical Engineering Laboratory, in which students take the course Chemical Engineering 435. The purpose of this course is for students to apply their previous knowledge in conducting experiments in the lab, gathering data, and using that data to design a process or part of a process. And this design has to be applicable, practical, and make sense. For that purpose, my main mission is to use my experience from industry and help the students understand how to apply their knowledge to solve actual problems that are applicable in industry in an atmosphere, an environment that is similar to what they will encounter in their future jobs.
We service an industry which is highly resistant to high levels or rates of improvement. We experience some of the lowest rates of productivity in any industrial sector. And my goal here at Purdue is to break through, assist both industry and students to become participants in industry, breaking through this level of productivity improvement that will enable industries to experience the kind of improvement that we've seen in other industries, such as computers and aerospace, shipbuilding, and dramatically reduce the cost of facility design and construction.
My goal for being a faculty of engineering practice at Purdue is to help students think about themselves and about engineering and about the world of work in a more broad and diverse fashion. Students know that engineering is about problem solving and thinking analytically and bringing quantitative analysis to the job. But I want them to think about the other things that they can do with that and how they can explore beyond just engineering to add value to companies across domains, not just in engineering, but in management, in the sciences, in the research and development, supply chain, and other aspects of industry that so desperately need them, and beyond industry, in government, in policy, and in many other areas that maybe they haven't thought of or explored.
I hope to bring problems from my consulting and my work experience into the classroom for the students so they understand why they had to have the theory, and so they get to experience a real-world problem. One of the many challenges in engineering is communication with the client, with the general public. Those of us in civil engineering, construction engineering, we often forget that we have the public that we're really serving, and they need to understand why we do some of the difficult engineering things that we do, how it serves them better. And in addition, we have to listen to what their needs are, learn how to identify what the problem really is from a number of different situations that the public will describe to us.
So we heard a number of ideas and visions and hopes for perhaps how the education might be, engineering, the education measures might be expanded in some dimensions beyond the technical. So Dan, if we start with you, you mentioned about you want to help students understand the kind of the why and the context of the technical work and perhaps the value of interdisciplinary collaborations with liberal arts, with business. So would you like to expand on that?
Sure, because it's extremely important to realize that the tough challenges that we have today and the hard problems that society in general is trying to address all require these different disciplines. And there's the technical expertise, but there is this why, there is a social context, there's an economic context, and there's a policy context, and even now, more and more, there's an international context that everyone has to work within. And to bring that to bear and to at least have the students aware of it at the undergraduate and graduate level puts them in a very good competitive position when they get out and they start working in the working world. And it also makes them better citizens for the overall society. So it benefits us all.
So Bob, you were talking about graduate students rather than having them locked up in the lab for 3 years on the grounds. You want to get them out on applied problems and things. So would you like to develop that idea?
How might that work? Yeah. Well, I had a happy accident happen to me one summer when I was a graduate student. None of the usual suspects were hiring research assistants or take a job with a professor and the professor's consulting firm, so I needed a job. And I went down the street and got a job at Lockheed. Didn't tell them I was going to go back to Stanford. Then I found out Lockheed would pay for my education. Not only that, Stanford had a co-op program for graduate students. What a thought. It's over 50 years old now. I managed to complete my doctoral degree working part-time at Lockheed, wrote a doctoral dissertation that Lockheed wanted, a doctoral dissertation that got a top-notch publication for me and my thesis advisor. There was one little problem with that, I think. My thesis advisor got absolutely no credit for the amount of money Lockheed paid me while I was working there to do his research. And you know how faculty incentives are. He really should have gotten credit for the amount of cash that Lockheed paid me to be a research assistant there. But it's very possible to do that. And with all the complex problems these corporations have around all these large systems, there's plenty of opportunity to bring graduate students in like I was as a co-op student to do research and actually add value to the company today.
So there are some other models out there, even ones that are 50 years old, that we might be able to tap into. We need to perhaps change some of the internal and external incentives. Brad, if I turn to you, you mentioned there about the assistive technologies and the way they perhaps have the students really understand why they're doing the engineering perhaps in a more holistic way, and perhaps you expand on how that's an avenue to open up the way we do engineering education to see more than just the technical.
I mentioned human-centered design, but when you go to looking at assistive technology, you can really use it as a model. In science, it was quite common to understand a complex system with the human body and really get the understanding of the normal functioning based on looking at diseases and disorders. They gave a lot of illumination of what would normally function. And I see assistive technology as also being a state where you have a lot of challenges, particularly with human-computer interaction. How does someone with a disability, work with something? And so that gives ideas of, solutions that have more biomimetics, artificial intelligence, as well as it's very human-in-the-loop system that you cannot just design a system and assume it will work for everyone. There's a lot of different case scenarios, which makes it very a dynamic system, which I think this is a perspective that's very useful for engineering students.
There's a sort of an organising principle. So, Mary, you mentioned about ways that we might help the students to better appreciate how their technical background and skill set can help organisations way beyond the technical function. Would you like to develop that a little bit further?
So I guess, students are pretty clear that their technical skills are going to be valued when they leave here from Purdue. But it's not always clear to them that all of the other things that we're trying to share and impart with them are as valuable. So I would say the first thing that we can do and we should do is elevate both the value of those other things and the visibility of those other things so that students feel like they're as valuable as the technical skills that they're getting because we treat them as valuable as those other things. That's number one. Number two, I would say, is modeling the behaviors. So if we say we want you to be a strong oral communicator or to be able to stand on your feet quickly and sell and pitch your idea, we should model that behavior so they can see what that looks like. If we say we want you to take risks and fail gracefully, we need to show them what that looks like by, providing examples of that in the classroom. Easier said than done, right? And then I think the last thing is encouraging them to experience the world in those other ways. So whether that's through a co-op or an internship, which I think we do a great job here at Purdue at encouraging, or whether that's trying out leadership through their own philanthropy and volunteer activities, whether they're leading or whether they're following, right? As an engineer, sometimes you have to follow for a long time before you get to lead. And you need to learn how to be a good follower as well as a great leader. So I think practicing those things and encouraging them to practice those things through philanthropy and through school activities and co-ops and internships is really important.
Thank you. So some real challenges there. As we draw this part of the program to a close, I want to ask each of you to respond or to give one big idea, one takeaway. If there's one thing you'd like this audience to remember after this about the way in which professors of engineering practice can really be engaged to help Purdue engineering to continue on a path of transformation, what would that big idea, that takeaway message would be?
Yeah.
Who wants to go first?
Yeah, I'll go first.
Okay.
Yeah, I've been harping on the theme of graduate students and research, and maybe you saw this article, "The New Normal in Funding University Science." It's been out there for a while, and they talk about the need for industrial partnerships in research. That the U.S. government is not going to be as able to generate as much research as they used to be able to. And it said two things in there. University faculty and business people often do not understand each other's cultures, needs, and constraints. And the other is, universities have to see firms as more than just deep pockets, and firms need to see universities as more than sources of cheap, skilled labor. Well, this group has been there and done that. We've got all the t-shirts, we've got the lapel pins, we've even got the coffee mugs we brought with us to prove it. So when we're trying to change graduate education here at Purdue, these people sitting right here have been there, done that, and we can offer lots of advice to the rest of the faculty on how to approach these industrial partnerships we're looking for.
Well, I'll follow on what Bob said, because it's about, in my mind, giving the students that leg up with this extra context, this extra exposure to make them more competitive and better prepared to go out and solve the problems, help society out in the long term, and take us forward. And the way we do that is to give them our practical experience, offer that to the faculty across the board. One of my favorite things, being a program manager, is the word schedule is a dirty word on campus. I'm trying to make it not a dirty word, and budgets and all of that other stuff. So bring that to bear, bring that practical experience, and have the students work through it and just struggle with it, and they'll get the practice and they'll be better off for the future.
I think, to me, and this was kind of mentioned before, the idea of giving students access to a big problem that really has an interdisciplinary aspect to it, and they see, okay, it's not just an engineering problem, but there's other aspects we have to consider, economics and describing the problem. So to me, that's where the professor of engineering practice kind of really excels, as looking at a global problem and knowing that there's so many facets and exposing students to those myriad of issues that they'll be exposed to in the future.
There's a reason why doctors practice medicine, because it takes a long time to master it. And engineering is no different. It takes a long time to master it. And so 4 years isn't long enough. And not to show our age, our extended age, but we have probably 200 years of lived experience in industry across the 10 of us. Ted's saying more, he's older than me. And so why not bring that to bear for the students? And unlike Dumbacher, I want our students to have an unfair advantage. I want them to have an advantage over other schools, and globally, I want us to have an unfair advantage. I want us to be better. And so if anything we do can add to that unfair advantage, I want to be a part of that.
So on that note, I want you to thank the panelists, so Bob, Mary, Dan, and Brad, but also our other two, Bob and Ted, and in the back, Andrew. So all of the professors of practice for being here and for contributing on video and live. Thank you. I want to acknowledge a couple of other people, Teresa, who's over there, who did all the fine video work, which I hope you appreciate, and collaboration, and also Cindy and Julie at the back, who helped organise the refreshments that you're going to partake in. So what I'm going to encourage you to do, we've actually got, if you're strictly to time, there's still 5 minutes. So what I really want you to do is, one, not run away because it's over in traditional fashion. Take the time, talk to these individuals, introduce yourself. This is the start of a conversation, whether you do it here, do it over there. This, if you haven't been impressed by the resource we have in our midst, which I'm sure a vast majority of the college does not appreciate the resource we have in our midst, then you're very hard to impress. So again, thank you for coming. Please, these folks have come, and they'd love to talk to you. They'd love to get more connected into the rest of the college. So thank you all, and I'll officially call the colloquium to a close, but please stay around, talk to all the professors of practice, have something to eat over here. Thank you.